let's talk about how work and energy are related. We've already hinted at this, but let's kind of give the real practical work here. So the work-energy theorem talks about how Newton's second law before we get into the work-energy theorem, we want to talk about Newton's second law, and that relates force and acceleration. Those are the two things we care about in Newton's second law for the sake of this discussion. So it relates Newton's second law. Now, if we combine this with our definition of work, remember that work will equal the force parallel times the change in x, right? So this is just our definition of work. Now, if we replace this F with net force equals ma, if we're assuming that there's only, if the net force we're assuming is parallel to our change in motion, which we'll just assume for sake of discussion right now, then we have work is equal to m times a times delta x. Now, if you go back through, you'll find that you've got a kinematics equation, v squared equals v naught squared plus 2a delta x. Now I can solve that for my a and get v squared minus v naught squared over 2 delta x is equal to a. Now, I don't expect you to know this or to remember this. I just want you to follow along. I should have said that earlier. I apologize. Just follow along and see that this logic makes sense. Then we have work equals m times v squared minus v naught squared over 2 delta x times delta x. The delta x's can cancel, and some of you might see where this is going. Work is equal to 1/2 m times v squared minus v naught squared, which can also be written as 1/2 m times a delta v squared, which this you'll hopefully recognize as the change in kinetic energy. So what the work-energy theorem says is that if you have an object that has work done on it, it will speed up because it gains kinetic energy. Now, yes, the energy can go other places as well, but the work-energy theorem is saying specifically if all of your work is going into speeding up the object, what will happen to the object? And again, that's because we derived it from starting with the definition of work and starting with Newton's second law. So we said if all of this force goes into causing an acceleration, it's not overcoming anything else, it's just accelerating, then that will cause this change in kinetic energy. And this is actually what lets us know that work is measuring the same kind of thing as energy, because we've already shown that this energy measures the same thing as other kinds of energies, so therefore work measures the same kinds of things as well. So what? Like I said, this justifies that that work will produce a change in the energy of a system. And that's what we care, is that you can do work to change the energy of a system.